Hello, welcome to our electronics education program. This is Vincent Chang. I promise you this lecture will be much easier compared to the previous one when we try to derive the current voltage characteristic for the MOSFET when it's operated in the triode region. MOSFET current voltage characteristics, part 3, formulation. So we're going to put all the formulation together. N-channel enhancement MOSFET. Source gate drain body. A circuit symbol on the right. The relationship between ID and the VGS and the VDS. So here's the relationship. The relationship between ID and VDS corresponding to different, with respect to different VGS. You have triode region on the left and saturation region on the right. So based on what we learned from the previous lecture, derivation of the current voltage characteristic in triode region, here's the answer. ID equals half mobility oxide capacitance, geometry ratio, width over length, channel width divided by channel length, to overdrive VGS minus VT times VDS minus VDS squared. Let's try to simplify the equation and use this symbol in the future, Kn prime. Half Kn prime defined by, Kn prime is defined by the product of mobility, electron mobility, and the gate oxide capacitance. On what condition this equation holds? Number one, the channel is formed. The channel is formed. VGS is greater than VT. And then what? The second condition on the left-hand side. The first condition tells us when the channel is formed. Otherwise, this equation has no meaning. If there's no channel, there will be no current. And then the second constraint is on the left-hand side. The one that I just showed you earlier, right? So what's on the left-hand side? The comparison between the VDS and the what? The overdrive. What's the definition of overdrive? VGS minus VT. If VDS is less than overdrive, then it's in the device is in the triode region. That equation holds. This blue equation holds. So in the triode region, this is the result. And this equation describes the relationship between the ID and the VDS and the VGS. ID, VDS, and the VGS. Now this equation describes the family of curve between ID and the VDS with respect to different VGS. What about the boundary, the green point? Because, let's say, if you go back, if you learn about the middle school math, it's a parabola. Passing through the origin, 0, 0, 0, right? If you plug in the VDS equals 0, ID is 0, origin. And then the coefficient of the second order term is negative. Means what? It's going downward. It's go like this way, not this way. If the second order coefficient is positive, the parabola going is like this way, right? So now it's going downward, like this way, not this way. So for this type of parabola, then you can try to find out the maximum point, the peak point. Let's put down the differential. Find out the maximum point, the peak point, partial ID, partial VDS, equals 0. Then what do you get? If you try to find out the maximum point, then you get this result. Take the derivative of VDS, then take out VDS, and 2. Then cancel it out. The second order becomes the first order. Then you get VDS equals overdrive, VGS minus VT. This tells us what? This tells us the maximum, the peak point of the parabola. The peak point of the parabola. The peak point of the parabola correspond to exactly the same as the pinch point condition, the boundary. The VDS equals overdrive. The VDS equals overdrive. What about the saturation region? Because ideally, if we don't consider second order effect, which I will teach you later in the future about the second order effect, if we neglect the second order effect, ideally, the current will remains the same when the device enters into the saturation region. Then the saturation current equals the peak current, right? The height of the red point equals the height of the peak point, the green point. Then you just get the height of the parabola equals the current of the saturation region. That's it. So we can replace the VDS by VGS minus VT. Then here's the result. If we replace the VDS by VGS minus VT, then 2 overdrive square minus 1 overdrive square. Again, overdrive is defined by VGS minus VT. Very simple, easy. So half Kn overdrive square. Half Kn VGS minus VT square. Kn is defined as what? Mobility oxide capacitance, which is Kn prime times W over L. Under what condition? In what condition this equation holds? I want to pause and think about this. Under what condition this equation apply? Under what condition this equation is valid? 2 conditions, right? Number 1, VGS is greater than VT. Number 2, on the right-hand side, saturation region. The right-hand side of the IV curve. The right-hand side of the ID versus VDS curve. VDS is greater than overdrive. All right? So now, you're supposed to be very familiar with the IV curve on the right, which give you the whole picture. Trial, saturation, and boundary. The relationship between ID, VGS, and VDS. Now I want to show you another curve on the left. On the right is the same vertical axis, the same curve, but different horizontal axis. On the right is what? Is VDS. On the left is watch carefully, GS is the VGS. And it's only describe the relationship between ID and the VGS in saturation region. I know a lot of beginners, when they first learned this, they got confused. So this is why I put different color. All right? All the red color corresponds to, are talking about saturation region, all right? All the blue color talking about trial region. So here's the red color, okay? Saturation. See, 10, 40, 90, 160. On the left-hand side, 10, 40, 90, and 160. What about VGS? The VGS on the left, 1, 2, 3, 4, 5. The VGS on the left, on the right is 1, 2, 3, 4, 5. On the left is the 1, 2, 3, 4, 5. It's another parabola describing the relationship between ID and the VGS in saturation region. This is what we call the square law. Very simple. ID is proportional to overdrive square. Overdrive square. Now, let's put everything together. The blue, trial region. This equation is valid under two conditions. Two inequality. Okay? And the red part describing the relationship for what? The characteristic for the transistor when it's operated in the saturation region. This is the whole picture of the IV. This slide is very, very important. I hope you can take a note or take a screenshot. Okay? Take a screenshot of this. This gives you the whole picture about the current voltage characteristics of the N-channel enhancement MOSFET. Now I'm relieved. Okay. Now I assume you already know this. We have come to the end of this lecture. Thanks for watching.